So here's some steps here. It says we want to write all fractions as improper fractions if they're not. We're going to multiply the tops with the tops, the numerators with the numerators, the bottoms with the bottoms, the denominators with the denominators. And then we'll write our answer in lowest terms. So these are the steps, but again, if we don't know why, it's easy to forget them. Okay? And this is one of your challenges, right? We're going to have a test on this. You're going to have to know how to add fractions, subtract fractions, multiply fractions, all of that stuff. So first, rewrite all fractions as improper fractions. So a 3 I can write as 3 over 1. And the 3/4 I can write as 3/4. The rules for multiplying say you multiply the tops and you multiply the bottoms. So if I do that, 3 times 3, oh, here comes our times table. We're going to have to know our times table again. We're going to get 9 on the top, and 1 times 4, we get 4 on the bottom. And we can leave our answer like this, 9 over 4 as an improper fraction, or we can change it to a mixed fraction, 2 1/4. And we always check if there's anything that can divide both so that it's in lowest terms. Now this, to start off with, this idea here, why? Why do we do this? Why does this make sense for fractions? So I'm going to break this down, and a really good way of understanding why is to make a connection with multiplication and something you've done before, which is area. If I did 2 times 5, I could represent that as a rectangle with a length here of 2 and a length there of 5. And if we wanted to count the area of that rectangle, that's 2 by 5, you would count the squares and you would find out that the area is 10. And you know that 2 times 5 is 10. Area is a way of showing multiplication. Area of rectangles is always length times width, so multiplication comes up with that. Okay? Now, what does it mean to multiply fractions? And I'll start off with smaller numbers. Let's say we wanted to do 1/3 times 2/5. Okay? So what I'm going to do on one side, I'm going to do area here. This whole thing, I'm starting off with a square that's 1 by 1. If I divide this side into thirds, this part here would be 1/3. And if I divided this side into fifths, these two would be the 2/5. One-third is here. 2/5 is there. Okay? That's the rectangle that would be 1/3 times 2/5. Do you see that that rectangle has 2 squares? But how many pieces is the whole thing divided into? Because the whole thing originally was a 1 by 1. Can you see my whole thing is now divided into 15 pieces? That's the sizes of the pieces. How many pieces do I have for my area?
2.
2 of them. That's the answer to this question with an area. What is 1/3 times 2/5? According to our rules, we should multiply the tops and get 2. We should multiply the bottoms and get 15. We can see it in an idea of area. It makes sense that you would do the multiplication bottom because that's dividing the whole thing up into how many, the size of the piece. Remember? when we talk about the bottom of a fraction, that's how many pieces the whole thing has been divided up into. Like a chocolate bar with 15 pieces. I don't know. I don't think there is one.
There definitely is not.
Well, you could make one.
My
Right.
brain is thinking, can I ask a silly question?
Yeah?
So 1/3 though would be all the way down and 2/5.
Right, but when we're talking about area, now you're thinking about 1/3 of the whole chocolate bar. When we're talking about area, that's a length
Right.
times a width. So I make my length 1/3
And
and my width 2/5.
that helps completely.
Okay? So this length here is 1/3 and this length here is 2/5. And I want to find the area because the area is length times width.
Right.
So let's do another one to see that picture again.
Just so you guys know, on a side note, obviously I've seen this course and many other math courses for 18 years, and I know fractions quite well. Have I ever understood multiplying fractions?
You just knew the rules.
I knew the rules, but I didn't, now to see that on paper, like, that changes my perspective. Which,
Like,
like,
it's not
in a
just
good
it's
way.
not just random that these rules exist. They exist for a reason. So if you had, I don't know how big I want to make this, right?
Let's
If-
go 2/3
2/3.
and 1/5.
Okay. So we imagine we have a rectangle that's 2/3 by 1/5. I'm going to just draw it here and say this is 2/3 and this is 1/5. Right? And I need to find that area. Okay? That,
Sorry for the interruption. Would all grade 12 students and their teachers please head down to the gymnasium now? That's all grade 12 students and their teachers. Please head down to the gymnasium. Thank you.
this is not to scale. I'm going to put a blue box around that. Now I'm going to actually draw it to scale. Okay? Mental math-wise, 2/3 should have been longer than 1/5. But we'll draw it correctly. Now I made a square that's 1 by 1. If the one side I divide into 3 chunks, then this from here to here would be my 2/3. And if the other side I divide it into 5 sections, then from here to here, that's my 1/5. This is the rectangle. Whoops, that's not blue. Here we go. I feel like it's bugging me that this is so badly drawn. I'm going to redraw it. It's supposed to look more like that. That's the shape of it. Now, if I look at dividing this chocolate bar into 5ths and 3rds, I would get a chocolate bar with 15 pieces. One of those pieces is 1/15. My piece sizes are 15ths. How many pieces do I have in this rectangle? I have 2 of them. Okay? So we're seeing a reason why, and if we're seeing a reason why, hopefully that helps you remember. Because you're going to have to remember these rules. And you know what? You know what's going to happen? You're going to mix rules up if you're just trying to memorize them. You know what kids do here? They get common denominators. You don't need the pieces to be the same size when multiplying. Pieces have to be the same size when adding. They don't need to be the same size when multiplying. But having those ideas mix with each other can sometimes be disastrous.
Like adding and subtracting versus multiplying and dividing rules for science.
Okay. And we have another one. We have 16, which I can make a fraction, 16 over 1, times by 1/3. So then, don't need a common denominator for multiplying, we're multiplying, we multiply the tops. You'd have 16 pieces in the end. How big are the pieces? 1 times 3 is 3. Each of the rules on their own are super easy. Only thing you're practicing right now is your times table. And this one is really hard. Like, ooh, your 1 times table. That was pretty intense. 16 times 1. And 1 times 3. Oh. Okay. Oh. This one gets me excited. But we'll. Sorry, this is an exciting question. You're like, why is this exciting, Mr. We're going to have fun with this one. First of all, we'll just apply the rules. Okay? If the rules are 2 over 7 times 7 over 4, and the rules are I need to multiply the top, so I go 2 times 7, I'm going to get 14. Do this next one in your head.
I have a question.
Yeah.
Once we get 28, right?
Give it away for
Wait,
everyone.
do we simplify it?
Yes.
So we just do whatever times 2, or divided by 10?
So here, 7 times 4 is 28. And in this one, we have to reduce this to lowest terms. So is there a number you can divide both the 14 and the 28 by?
2.
You can divide them both by 2. If you divide them both by 2, you will get 7 here and 14 here. Are we done? Or can you divide both of those by something?
You can divide both of them by 7.
You can divide both of them by 7. So then this becomes 1, and this becomes 2. This is the lowest terms. 1/2. Now, if you think about it after, does it make sense that if you had 14 out of 28 things, you have half of them? If you had 7 out of 14 things, you have half of them. So the lowest terms is writing 1 out of 2. And we always want to write things in lowest terms. Okay. I'm going to really push you hard with your math. You figured out 7 times 4 was 28. Okay, you guys ready for some mental math? Get your brains ready? I'm going to give you a mental math question timesing. Right? You just did 7 times 4 is 28. I want to see how fast you get this one.
I know what he's gonna ask.
What's 4 times 7? 7 times 4 is 28. What's 4 times 7?
28.
28.
Oh wait, I read it wrong.
You're the one who came up with it.
I pumped it up, right? And you can, like, right? But if you know 7 times 4, does it make sense that if you flip those, they're the same number, right? Agreed? 7 times 4 is the same as 4 times 7. And if the rules are multiply the tops, multiply the bottoms, and I just said that 7 times 4 is the same as 4 times 7, did I change the answer to this question? This is going to be exactly the same answer. There we go. Would you agree this is exactly the same answer? Because 4 times 7 would give you 28? Same as 7 times 4 would give you 28. But something cool is going to happen by me switching these around. What's 7 over 7? 1. Oh, so this is the same as this? Yes. What's 2 over 4 times 1? 1 times table. 2 over 4. Can you reduce 2 over 4?
Yeah,
What is it?
divided by 2.
Divide by 2. We get a half again. I like, there is ways in fractions to make your life easy. So, if you are multiplying fractions, you can do what I just did here and switch the numbers around. Sometimes that makes you able, like, this is 1. That is so much easier math. Right? Timesing by 1 is pretty. Should we do a test? A whole test? Hour-long test, all practicing times it by 1?
Yeah.
Yeah? Do you think you'd get 100%?
No.
No, you'd leave one blank by accident.
Probably.
Could happen, right? So, in fractions, you are perfectly able to do this. You are, like, we had this original question was 2/7 times by 7 over 4. You're perfectly able to multiply the tops and multiply the bottoms. But you can also reduce fractions if possible, and you are not limited to just the individual fractions. So for example, I could do in this question and say the 7 and the 7 could simplify to 1 over 1. And the 2 over 4, those both divide by 2. I could simplify that to be 1 and 2. Things get a little bit messy sometimes. I try to color code so you can see what's happening here. But now if I multiply the tops after I've simplified, what's 1 times 1?
1,
You ready for that test, Dave? What is 1 times 2?
2.
Look at that. How nice is that as an answer? I can even give you ones that look really scary. What do you think 3 over 117 times 117 over 5 is equal to?
What?
You have the answer? Yeah, just one thing, just with this class in particular, I've been noticing. We have class right after lunch, which means you should be fine. Make sure you go to the washroom during lunch hour. You should be fine until the class ends, and then you have a 5-minute break. The administration really wants to make sure people are not using the washrooms during class time. Sometimes you have to, and that's understandable, but try to make it a habit of going before class and then going in between. Today is fine. Once we're done the notes, can you wait till then? Then that'll be fine. Okay, so 3 over 117. Anybody got an idea what this answer might be? No? There's a way to do it so you don't have to do anything complicated math.
3 times 117, 117 times 5, 110.
That's big numbers though. Don't make-
100 you could do 110.
Yeah, but you're making it way too hard. How about if I did it like this? I said, this doesn't matter.
370? Wait, no.
What if I change the order for you? Right, because 5 times 117 is the same as this. What's the answer going to be? See the shortcut?
107.
Oh, you're there's
3/5.
3/5. This is 1. So this is just 3/5 times 1. 3/5 makes your life so much easier. These are things I love in math. When you find ways of making it easier, I'm always looking for those. Is there ways? It's like cheating the system, right? I told my class in period 3 about cheating the system. I was either going to become a con artist or a math teacher. I had to decide, and I didn't want to go to jail, so I was like, I'll go math teacher. Because this feels like I'm cheating. Like the rule says I should multiply 3 times 117, and I mean, it looks fun, but it's way easier if we can cheat the system. Okay, couple to try. So in your notes, you've got 1 to try on your own. There's 1. How many to try on your own? 1, 2. Is there 3 to try on your own? There's 3 to try on your own. Try one. I'll put the answer up in a bit.
Now would be a time to quickly go. And when the numbers get big, that gets really big.
So to check, if we're multiplying this together, multiply the tops. You have 7 times 6, and we have a negative there. So negative times a positive will be negative. So I'll get negative 42, and 3 times 5, 15. Okay? Now we have to put it in lowest terms. We have a couple of options here. Okay? Option 1 is maybe you see, okay? Option 1, maybe you're really good at mental math and you see that both of them can divide by 3.
Which isn't easy to see.
That isn't easy to see because this one on the top is going to be 14, and that's probably beyond your times table. And 15 divided by 3 is 5. Which as a mixed fraction, negative, there's 2 full ones to make 10, leaving you with negative 2 and 4 fifths. Okay? Option 2. Option 2 I'll do in green. Maybe you can't see what you have to divide them by. The numbers are too big. Maybe you want to instead start by changing it to a mixed fraction. How many 15s go into 42? 1 15? 2 15s would be 30? 3 15s would be 45, too much. So you know that this is negative 2. And if I did 30, 2 15s is 30, that would leave me with 12 left. And here,
Easier to see.
I can reduce this. I can see easier that I can divide by 3, get the same answer. So sometimes if one thing is hard, maybe you want to change it to that mixed fraction and work with it that way. Option 3, let's rewrite it again.
The better option.
Well, if you can simplify early, life gets easier. 7 and 3, they both don't divide it by anything. 6 and 5, they don't divide by anything. Then I start looking diagonally. Hey, the 6 and the 3, they both divide by 3, leaving me with 2 and 1. Beautiful thing now. My numbers are smaller, so now it's just negative 7 times 2, negative 14. 1 times 5, 5. Look at that, we got our answer already reduced. Reducing early means you don't have to reduce later. If you're going to have to reduce, you can either do it early or later on. Which, doing it early means your numbers are smaller. Like, I think 42 divided by 3 is not easy. Anybody know the trick that you can tell a number right away you can divide by 3? Like when I looked at 42, there's a trick saying, I know you can divide by 3. Like 78 you can divide by 3, but you cannot divide 82 by 3. How do I know this?
I just knew if you divided by 15.
How do you know a number you can divide by 3? The trick is the following. If you add up the digits, 7 plus 8 is 15. 8 plus 2 is 10. If the number they add up to divides by 3, the original number divides by 3. A really crazy mathematical coincidence. So for example, 123, what do those 3 numbers add up to? 1 plus 2 plus 3. 6. Can you divide 6 by 3?
Yeah.
So you can divide 123 by 3. It happens to be 41. Okay?
Because why wouldn't he know that?
That's a cool trick for dividing by 3. Next one. We have a negative times a negative. I know my answer is going to be positive. I'm going to do this one directly first. So fraction rules are, if I'm multiplying fractions, I multiply the tops. 5 times 2 is 10. Multiply the bottoms. 4 times 3 is 12. Is there a number you can divide both those by? Yes. You divide them both by 2. If you divide the top one by 2, you get 5. Divide the bottom by 2, you get 6. Which means I could have simplified something earlier. Can I simplify 5 and 4? Is there a number that divides both of those? No. Can I simplify 2 and 3? No. How about 2 and 4? Yes. I can divide both of those by 2. That would leave me with 1/2. And now, 5 and 3? No. But -5 times -1 is 5. And 2 times 3 is 6. You have to reduce it to lowest term sometimes. You can do it at the end, or you can do it early. You might even want to take out like a different color pen when you do this. It's nice so that you can see what you've done and what you've changed them to. I just changed the 2/4 to 1/2. Doing it directly. Everybody's favorite 8 times table. 8 times 3.
24.
24. Good.
So 24 over 10.
24 over 10. 5 times 2 is 10. Is there something you
Two.
can divide both of them by? Divide them both by 2.
So 12
12
over 5.
and 5. Method 2. Check. Is there something you can you simplify 8 over 5? Anything you can divide both of them by? No. What about 3 over 2? No. Start working on diagonals. 3 and 5?
No.
8 and 2?
Yep.
Yes, they both divide by 2, so I'm going to take out my purple pen. If I divide this one by 2, I get 4. If I divide this one by 2, I get 1. And now I have 4 times 3 on the top and 5 times 1. Let's go.
Let's.
So at the beginning of the class, I tried to give you an area example, explains why it is that it works, that the tops multiply together and the bottom is multiplied together. Very important that you remember how to do these things, because mixing up the rules means your math is going to go all over the place. We use fractions a lot in everyday life. Like if something is half off when you go to buy in the store, you're multiplying it by a half, you're multiplying by a fraction. We get really good at halves because that's a good sale, and then you like to do the mental math, right? I like it when I get to do mental math that makes the price cheaper. If something was $80, it's half off, how much are you going to pay?
What?
Something's $80, it's half off, you got to pay 40, right? They like the half sale. Not very many stores will be like, hey, we're having a 3/7 sale. Everybody like, I don't want to do that math. I'll go to the half off sale. Happy. Okay, so Mr.
Which
Shirk
would be better anyways.
is going to hand out multiplying fractions.
I have a question.
I have the answers on the binder up at the front. So I would say do 2 and then come up and check. If those 2 are good, then do 4 more and then come up and check. If those 4 are good, finish the page and then start the next page.
I have a question.
Yes.
With this
Let me
picture-
just pause the video here. I think